I think it's helpful always to at least have a little class discussion about the conclusions. That way, if you aren't really understanding the lab, this is your opportunity to actually gain some understanding and make sure you're doing okay for preparing for the quiz and the assessments coming up. So let's just work our way through them. The first thing we changed in the lab was the substrate concentration, like number 1 is asking about. So how do we do that? How do we change the concentration of substrate? Yeah. We added paper clips, right. So the substrate, was it the paper clip or was it the toothpick?
The substrate was paper clips going in.
What was the substrate itself?
Or the toothpick.
The toothpicks, right. So we reduced the amount of substrate by adding in the paper clips. What did that do?
It made it harder for the enzyme to break down.
Do you have evidence of that?
Yeah, because it took longer.
Okay. And then in your lab report, obviously, you would say how much longer it took to break the 10 toothpicks. So your answer for the toothpick conclusions for number 1 might sound something like decreasing the concentration of substrate, which remember were the toothpicks, reduced the speed of the enzyme, which was your hand. And I'm just making this up, but you should use the actual data. And then you could put, for example, breaking 10 toothpicks took on average 5 seconds longer when we added in the paper clips. Everyone buying that? Make sure you use numerical evidence. Okay, you can't just say this is what happened. You have to support it. For our second question, it's the same type of question, but it's asking how temperature affected the rate of your hands breaking the toothpicks. What patterns did you see there? But I still think we saw a general trend of what? Slower or faster when we put our hands in the ice? Slower, on average, right. So your answer for number 2 would sound similar to number 1. Enzymes only work the best at a certain temperature. Cooling off the enzyme slowed the reaction down by an average of, let's say, 2 seconds to break 10 toothpicks. We good on that one? Explain the relationship between the enzyme's shape and function for number 3. What happened when you changed the shape of your hands, and how did we do that? We taped our hands to change the shape of them. Did that affect how your hands worked or not?
Yeah.
Absolutely. It slowed them way down. I think this is the biggest slowdown that we had in the whole exercise. Taping our hands to change the shape slowed them down in breaking 10 toothpicks by, let's say, an average of 20 seconds. Similarly, actual enzymes will not function as well if their shape is damaged. Compare and contrast the lab as a representation for an enzyme function to the actual function of the enzyme. So what was good about our model, because we didn't really use enzymes and we didn't use substrate, it was a model, it was a simulation. So what was good about the simulation? What did we accurately show? Probably relates to those first 3 questions we just answered, right? Tarun? Right. So we showed how an enzyme's function, or how quickly it works, can be influenced by substrate concentration temperature, and what was the last one? And shape. Just like we talked about in our bell work a couple days ago, when enzymes control a reaction, are they used up? No. Were our hands used or changed when we broke the toothpick, when we carried out that reaction? No. So that is also accurate. What were some things that were not accurate about our model, our simulation? What did we not show? We showed that enzymes, your hands didn't work as well when they're really cold. Do you think enzymes work well when they're really hot? Did we show that in our model? No. What else? Let's get one more. What else didn't we really show in our model or simulation? What type of reaction did we show by breaking the toothpick? What's the reaction called that breaks molecules down that we studied? It's going to be on your quiz Friday. Yeah? Katie? Hydrolysis. Do enzymes just break molecules down? No, what else can they do? What other types of reactions can they catalyze? Yeah? Did we build anything in our simulation? Absolutely not. Good. Questions on 4? I thought this one was a little bit harder, so hopefully writing, kind of annotating what I'm saying helped you. What are some possible sources of error or inconsistencies in your data? If we pull up the range, right, let's look at some data that reflects consistencies or inconsistencies. There is a significant range here, and an even better measure is the standard deviation. So why were these numbers high? Or why aren't they lower? Kinsler?
Not all of us tape their hands the same way.
Good. Not all of you taped your hands the same way. Maybe some of you did not put the tape as tight. You can still use your fingers better than others. That's an excellent possible source of error. What else? Chris? Maybe not everyone kept their hands in the ice for a long enough time. Or maybe they waited a long time afterwards and their hands warmed up. I didn't say break 10 toothpicks exactly 5 seconds after you pull your hands out the ice. So people were free to, take their time or hurry up back to their station and break the toothpicks. Could that have affected our results and the consistency? Absolutely. What else? Yeah. Right. Some people might have stronger fingers. They might be quicker. Did we run the experiment with the same person breaking the whole time? No. We had changed every group had a different person. So that could have contributed. I'm sure it contributed to inconsistencies or our higher range and standard deviation. Number 6, what was the control group independent variable, dependent variable in the experiment? Can anyone help us out with one of those 3? Nick? Right, so it was in the absence of what we tested. So we tested when we added paper clips, did that affect the rate of your hands? When you added ice to your hands, did that affect the rate? The control has nothing that you're testing, so it would have been part A with 100% toothpicks. Excellent. Do you want me to write this one down or not? No? Okay. What about the independent variable? That's what you're testing. So it's like the opposite of the control. Yeah?
If your hands went
Right. So we tested the temperature by putting our hands in the ice, adding paper clips or changing the substrate concentration, and then changing the shape of your hands by taping them. Good. Let's go to the extension number 1. We already kind of answered this, but just to make sure you're understanding it, does our simulation, is it showing hydrolysis or dehydration synthesis? Hydrolysis, right, which is breaking molecules. We aren't building any toothpicks. We're not putting them back together. Good. We did number 2 in the Bellworks. Let's skip over that one. Number 3 in the extension. Write an equation that could predict the average number of toothpicks broken by our enzyme hands at any time for each part of the experiment, and then predict how many toothpicks would be broken after 24 hours. So let's set up some variables here. People struggle with this last class, so I'm going to put it on the board. So we are on extension number 3. So let's define y as the number of toothpicks in the bowl. And this is pretty simple algebra, so I think all of you have been exposed to this. And x would be our time. And what unit did we use for time? Seconds. So let's add that. So for part A, which was 100% toothpicks, it says we need to make an equation for how many toothpicks could be broken at any time on average. So the first thing you need to do is look at your rate of toothpicks broken on average. The toothpicks broken were 26, right here, 26 toothpicks. Excuse me, 10 toothpicks were broken in 26 seconds. So 10 toothpicks broken in 26 seconds. So I want to find the number of toothpicks. I'm going to start with that on my left side. Y equals, if I'm breaking the toothpicks, how can I represent that in terms of x and y? If y is the number of toothpicks, if I'm breaking them or getting rid of them, I would make that value negative, right? You found that? How many am I breaking each second? If I broke 10 toothpicks in 26 seconds, how would I figure out how many toothpicks are broken each second? Because that's what x is defined as, 1 second, right? Well, all you do is divide. 10 divided by 26. So 0.38 toothpicks each second. So y would equal, that would be your rate, or like your slope, 0.38 x. You found that? I'm going to let you do the rest for part B, C, and D. How would I find how many toothpicks are broken after 24 hours? Yep. Right, 24 hours is the time, so you'd have to plug that in for x, but make sure you convert it to seconds, because that's how x is represented in our equation. Question? No? Okay. We good on number 3? Let's do number 4. Number 4 is a similar problem. Assume the toothpicks are a waste product in a cell called hydrogen peroxide. The enzyme hands break down the hydrogen peroxide at the average rates observed in your experiment, which you've already kind of calculated. A cell begins with 100 molecules of hydrogen peroxide. So the hydrogen peroxide is like your toothpicks. We're breaking them down. Normal cell activities produce 10 molecules of hydrogen peroxide each minute. So unlike our simulation, in this scenario, you're adding in toothpicks at the same time where you're breaking them, which is probably how a cell would really work. If a cell's functioning, it's going to be constantly producing waste. How long will the enzyme hands have to work for all parts to break down the hydrogen peroxide? Well, let's stick with part A. We already have a representation of how many toothpicks are broken down on average each second. So that's y equals, negative 0.38x. In the question, it says there's 100 toothpicks to start with. So how would I represent that in my equation? Remember, y, our left side equals the number of toothpicks. So how would I add 100 toothpicks to y? Plus 100, right. And it says that 10 hydrogen peroxide or toothpicks are added each minute. But x is in seconds, right? So we need to convert that to seconds. So how many toothpicks are added each second? 10 are added each minute. How many seconds are there in a minute? So we divide 10 by 60. So there's 0.17 toothpicks added each second. If we're adding the toothpicks, should my coefficient be negative or positive? Positive. So this would be 0.17x. And then to solve for how much time does it take to get 0 toothpicks, how would we do that using this equation? What variable represents the number of toothpicks? Y. So you plug 0 in for y, solve for x, and that's your answer. You can combine like terms, right? We now do that, and then just solve for x. So a lot of times scientists will do this from their experiment. To apply it to a different situation, they'll make a mathematical model to make their results a little bit more powerful. I wouldn't want to sit here and break toothpicks for 24 hours. But using our results, we can make a model that lets us calculate that outcome very quickly, which I think is kind of cool. Any questions on how to do the math equations, the math models from our results? I've done one for you. The other 3 will be the exact same process. So hopefully this guidance will help. Five. How does the standard deviation correlate to the reliability of your data or the consistency of your data? So if you have a high standard deviation, does that mean your data is consistent or inconsistent? Inconsistent, right. A standard deviation measures how far away each number varies from your average. So it's like the average away from the average. So if you have a high standard deviation, that means your numbers are more spread out. What would we do to lower the standard deviation? We kind of already answered this. We could make everyone tape their hands the same way. We could say you have to start breaking toothpicks 10 seconds after your hands were on the ice for exactly 1 minute. We could have all the same person break the toothpicks the whole time. Those would probably increase the consistency of our data and decrease the standard deviation. Are there any other questions you have before I turn you loose?